55 euros of AI coding. What did I actually get? 5,000 anti-gravity credits. 55 euros. Almost one full day of autonomous coding. And at the end, I had around 180,000 tokens of working code committed to Git. That sounds like a lot until you calculate what those useful tokens actually cost. Because when we hear about AI pricing, we're often told that 1 million tokens costs only a few dollars. So how did my real-world experiment produce an effective cost of around 305 euros per million useful code tokens? Let me show you what happened. If you're a developer who is new to AI, you have probably heard claims like $2 per 1 million tokens. Sometimes, this is followed by a dramatic comparison that is roughly equivalent to the complete works of William Shakespeare. And naturally, you think, wow, 1 million tokens for only $2? I could build entire applications for almost nothing. But there's an important detail hiding behind that number. That price may cover only the input tokens, the information you send to the model. The output is billed separately, and it is usually more expensive. For a simplified example, imagine paying $2 per million input tokens and $10 per million output tokens. 1 million of each would cost $12 in total, or roughly 10 euros and 50 cents. And honestly, charging more for output makes sense. You might send the model a one-line instruction. Write me a 100-line love poem. Your input is tiny, but the model still has to generate all 100 lines. So even at $12 for 2 million combined tokens, AI still sounds extremely affordable. But coding agents do not behave like simple chatbots. They are token black holes. A coding agent does not simply read your request and produce one answer. First, it reads your ticket. Then it searches through your project. It opens source files, configuration files, tests, logs, and documentation. It analyzes the existing architecture. It generates code. It runs the compiler. It discovers an error. It reads the error message. It edits the code again. Then it runs the unit tests. One test fails, so it reads more files, makes another change, and repeats the process. During all of this, the agent is consuming its available usage allowance. Depending on the service, that allowance may be measured in tokens, requests, credits, or some other internal unit. In anti-gravity, it is measured in credits. Those credits are not the same thing as model tokens. They're the platform's billing and usage unit. But the code produced by the agent can still be measured in tokens, which allows us to estimate how much usable output survived at the end. And most of the agent's activity will never appear in your final application. Its allowance is consumed while reading context, analyzing the repository, processing terminal output, attempting failed solutions, and generating intermediate code that may later be replaced. That made me wonder, what is the real cost of the code that survives? So in July 2026, I decided to test it. I was already using Google's Antigravity coding agent on a real Java and Spring Boot backend application. This was not an empty demo project or a build-a-to-do app tutorial. The existing codebase contained approximately 425,000 tokens of Java code. I purchased an additional package of 5,000 anti-gravity credits for effectively 55 euros. Then I gave the agent one development ticket after another. I let it inspect the project, generate code, compile the application, run the tests, fix its mistakes, and continue working until all 5,000 credits had been consumed. But before looking at the result, I needed a definition. For this experiment, I created a metric called a useful token. A useful token is part of generated code that successfully compiles, passes the relevant unit tests, and is ultimately included in a Git commit. Failed attempts do not count. Code that gets generated and then deleted does not count. Explanations, plans, terminal logs, and repeated analysis do not count. And even this definition is generous because committed code is not automatically good code. It can compile, pass its tests, and still be badly designed, unnecessary, or inconsistent with a wider application. But at least this gives us something concrete to measure. For almost an entire day, anti-gravity kept working. Ticket after ticket, Files were created. Existing classes were modified. Tests were written and executed. Errors appeared and were corrected. Eventually, the credit balance reached zero. All 5,000 credits were gone. So what did I get for my 55 euros? Approximately 180,000 useful code tokens made it into my Git repository. And despite all that generated code, the application was still not halfway to a customer-ready MVP. Now let us calculate the effective cost. If 55 euros produced 180,000 useful code tokens, then 1 million useful code tokens at the same rate would cost approximately 305 euros, not 10 euros and 50 cents, around 305 euros. That is roughly 29 times higher than the simplified face value token price comparison. To be clear, this does not mean that the advertised API token prices are false. This experiment demonstrates something else. Raw model token pricing does not tell you the real cost of producing usable software through a coding agent. The advertised number tells you what direct model input and output may cost under a particular pricing structure. It does not tell you how many internal operations a coding agent will perform while searching your repository, planning changes, using tools, reading compiler output, fixing errors, and repeating unsuccessful attempts. And it definitely does not tell you how much working software you will receive at the end. In my case, the actual transaction was simple. I paid 55 euros for 5,000 anti-gravity credits. Those credits produced around 180,000 tokens of compiled, tested, and committed code. At that rate, 1 million useful code tokens would cost approximately 305 euros. That does not prove that every coding agent will have the same cost. It does not even prove that my next experiment will produce the same result. But it does show why price per million model tokens can be misleading when developers use it to estimate the cost of building an application. The more useful questions are, how much does one completed ticket cost? How much does one accepted feature cost? How much does it cost to reach an MVP? And how much human review and rework are still required afterward? In my experiment, the result was not almost free software. It was 55 euros for 180,000 committed code tokens and a product that was still far from finished. AI coding agents can absolutely produce real value. But when someone tells you that 1 million tokens costs only a few dollars, remember, that number does not represent the complete cost of an autonomous agent building software inside a real code base. You're paying for the entire process, not only the code you keep. Raw model tokens may be cheap. Useful software is not. And that is exactly why this channel is called AI, Proof Before Hype.